Welcome to my tutoring session in chemistry. In this video, I'll talk about thin layer chromatography. The current video is part 2 in the thin layer chromatography series, and I'll explain the various detection methods commonly employed in the thin layer chromatographic separation method and the applications of TLC. Most of the organic compounds are colorless, and when we try to carry out the separation of these colorless organic compounds by employing the thin layer chromatographic separation technique, we'll end up with components that are separated by TLC that are colorless. So you'll not be able to visualize these colorless spots as the compounds being separated are colorless in nature. Now, if we cannot identify these spots or locate these spots, we cannot calculate their RF values. Now, RF stands for retention factor or retardation factor. So how do you identify these colorless spots separated by TLC technique? There are several visualization or detection methods available for identification or location of this colorless spots that are separated by TLC technique. Two methods are available. One is the chemical method, other is the physical method. Now the chemical method involves the usage of spray reagents, and the chemical method is a destructive method as the sample is destroyed before detection of the separated components. The second method is the physical method, which involves the usage of iodine-chamber, UV chamber, and the physical methods are non-destructive methods as the sample is not destroyed. So the sample can be visualized by physical methods without destroying the samples. And by densitometric method, which is a in situ method, you can measure the optical density of the separated components. Let me begin with the first method, that is the chemical method that employs the visualizing spray reagents. Let's say we are given with a sample mixture S. Now the sample mixture is abbreviated as S, glycine is abbreviated as G, alanine is abbreviated as A, tyrosine as T, phenylalanine as P. So we are trying to separate the given sample mixture into individual components by employing the TLC technique. So you take a TLC plate, draw the baseline at the lower end of the TLC plate, and this will be around 1 to 2 centimeters from the lower end of the plate. And draw a reference line at the upper end of the TLC plate, and this will be around 0.5 to 1 centimeter from the upper end of the TLC plate. And this reference line is for the solvent front, because you should know when to stop the separation process or the development process. So once the solvent front reaches this particular reference line, you can stop the separation and remove the TLC plate from the development chamber. Now the concentration of solution is usually a 1% solution, and the sample solution is prepared using low boiling volatile solvents like chloroform, dichloromethane, and acetone. And make sure the diameter of the spot does not exceed 2 to 3 millimeters. And we are employing water in order to prepare the sample solutions, as the amino acids are highly polar and soluble in water. So apply the given sample mixture on the baseline and place the TLC plate in the chromatographic chamber and remove the plate after the solvent current has reached the reference line. And later you can dry the plate. Now if the components that are being separated, if they are colored, life is made easier for the person who is carrying out the separation by TLC technique, as the visual assessment of the chromatogram is easier and the RF values can be calculated immediately. So very few compounds are colored. They have the natural color of their own. Now in the present case, we are trying to separate and identify 4 amino acids in the given sample mixture. Yes, that is phenylalanine, tyrosine, alanine and glycine. And they are colorless compounds. And after the separation is done, we have to identify or locate the spots. So this can be done by spraying the TLC plate. So make sure that you dry the plate before you spray with the reagent. Now nitrogen reagent is the recommended reagent for the identification of the amino acid spots separated by TLC technique. And when you spray the TLC plate with the nitrogen reagent, you see the purple colored spots appearing. And the reason for appearance of these purple colored spots is due to the chemical reaction between the ninhydrin reagent that is sprayed onto the TLC plate containing the amino acid spots. So the sprayed ninhydrin, it chemically reacts with the amino acid spots on the TLC plate, and as a result, due to the chemical reaction between the amino acid and ninhydrin, the purple colored spots are formed. So we are taking advantage of the fact that chemical reaction between ninhydrin and amino acid results in a colored product. So any reagent that you are making use of should be able to react with the components being separated, and that should result in a colored compound. Now there are several reagents available for different class of organic compounds. Like phenols can be identified using ferric chloride reagent. Aldehydes and ketones can be identified using 2,4-DNPH reagent. DNPH stands for dinitrophenyl hydrogen. And drag and drops reagent is commonly used for detection of alkaloids. So much for the detection of colorless compounds by chemical method. Now let me explain the physical methods that are commonly employed for detection of colorless compounds. There are 2 widely used methods for detection of the colorless compounds that are separated by TLC technique. They are UV chamber method and Iodine-Chamber method. Let me begin with the UV chamber method. Now UV cabinets are commercially available, and there is provision in the UV cabinet for detection of the separated components at a shorter wavelength of 254 nanometers and detection of fluorescent substance at a longer wavelength of 365 nanometers. There is also a provision for observing the colored compounds using white light. So I have three options in the UV cabinet that is commercially available. Wavelength of 254 nanometers, 365 nanometers, and also white light that is used to observe colored spots in case the compounds being supplied are naturally colored. Now, what is the criteria or requirement for the compounds to be detected by UV method? Now, compounds should be having chromophores, or there should be chromophoric groups. So compounds with chromophores are UV active. So what are the chromophores? Now, chromophores are group or part of a molecule that are responsible for characteristic absorption of radiation at a wavelength of 254 nanometers. So compounds with chromophores are UV active and absorb the UV radiation at a wavelength of 254 nanometers. Now, chromophores are covalently unsaturated. They are characterized by the presence of double bonds. And these double bonds may be conjugated or they may be unconjugated. So what do you mean by a conjugation? A conjugated system is one where you find the alternative arrangement of single bond and double bond. So even azo groups, you find unsaturation between two nitrogen atoms. So compounds with chromophores, they absorb the UV radiation. So even aromatic system or aromatic compounds, they have conjugation. As you can see, the alternative arrangement of three double bonds and single bonds in a cyclic manner. So you find conjugation even in aromatic systems, and therefore aromatic compounds, they strongly absorb the UV radiation at wavelength of 254 nanometers. Why this wavelength of 254 nanometers fixed? Because at this particular wavelength, most of the organic compounds, they absorb the UV radiation. So when the compounds are colored, after the separation is done by the TLC technique, you dry the TLC plate and you can observe under the white light or even using the natural light. Now the TLC plates that are commercially available, you find the silica gel layer is coated over the aluminum sheets, and this silica gel layer is commercially available packed by aluminum sheet. It is impregnated with fluorescent material like zinc sulfide. So when the TLC plate is exposed to the UV light, when it is placed under this UV cabinet at a wavelength of 254 nanometers, you see that there are bright spots or dark spots against a fluorescent background. So the TLC plate that you have developed using for the separation of the given sample mixture made up of amino acids, phenylalanine, tyrosine, alanine, and glycine, they appear as bright or dark spots against a fluorescent background. So the fluorescent background is due to the material zinc sulfide. So the silica gel layer that is impregnated with zinc sulfide, it absorbs the UV radiation at 254 nanometers and they give fluorescence. Whereas the spots, they quench the fluorescence and hence they appear as bright or dark spots against a fluorescent background. So mark the spots with pencil and calculate the RF values. Now the commercially available TLC aluminum sheets, you generally find this label silica gel GF254. Now what is the meaning of this label silica gel GF255? Now the letter G, it stands for gypsum. So gypsum, also known as calcium sulfate. So chemical it is calcium sulfate, also commonly called as plaster of Paris. Now this gypsum, it enables strong binding of this silica gel layer over the aluminum sheets. And the letter F stands for fluorescent material. It indicates that the silica gel plates, they are impregnated with fluorescent material like zinc sulfide. And the number 254, it means that the fluorescent material, that is zinc sulfide, it absorbs at a wavelength of 254 nanometers and gives fluorescence. So that's the meaning of this label silica gel GF 254. So in case of spray reagent method, you spray the developed and dried TLC plate with nitrogen reagent, and because of the chemical reaction between the sprayed nitrogen reagent and the spots of amino acid, you see purple colored spots. So mark these spots, the boundary of the spots with pencil, and calculate the RF value considering the center of the spot. So RF value is calculated by dividing the distance traveled by the components from the baseline divided by the distance traveled by the solvent from the baseline. An important caution. So it's always important to be cautious with the UV light. To protect your eyes and skin, avoid looking directly into the light. And better you wear safety goggles and stay safe. And avoid exposing yourself to the UV light. Now moving on to the iodine-chamber method. Now like UV chamber method, iodine-chamber method is also used for visualizing unsaturated compounds. So the colorless compounds that are separated by the TLC technique cannot be visualized. These spots cannot be visualized or cannot be perceived by the naked eye. So after the development is done, dry the plate and you can introduce the developed and dried TLC plate using tweezers or forceps into the iodine chamber. And how to prepare this iodine chamber? Now iodine chamber can be prepared by intimately mixing crystals of iodine with either silica or alumina powder. And make sure that you are transferring this intimate mixture of iodine crystal and silica or aluminum powder into a amber colored bottle, as iodine is photosensitive in nature. So after introducing the plate into the iodine chamber, after a period of time, you will see that brown or amber colored spots begin to appear slowly. And this is because of the sites of unsaturation in the compounds being analyzed. So a complex is formed between the unsaturated sites and iodine. And in case of the sample mixture, now the sample mixture that we are separating, they have sites of unsaturation like aromatic rings in case of phenylalanine and tyrosine. So they react with iodine. A complex is formed between the sites of unsaturation and iodine. And you call this as charge transfer complex that can be seen as a brown color or amber colored spots on the TLC plates. Now the aromatic system, it acts as a donor while iodine acts as an acceptor. and a complex is formed between the donor and the acceptor, resulting in formation of a brown colored complex. So amber or brown colored spots are seen against a white background. Now in the iodine chamber, now the iodine, it is highly volatile in nature. It sublimes and vapors of iodine, they fill the chamber. And generally, it takes more time for the brown or amber colored spots to appear. So the iodine crystals, they sublime vapors of iodine, they fill up the iodine chamber, and slowly, because of the charge transfer complex formed between the compounds and the iodine, amber or brown colored spots begin to appear against a white background. So mark these spots with pencil and calculate the RF values. If you delay in calculating marking the spots will disappear because of the volatile nature of iodine. So mark the spots with pencil immediately and calculate the respective RF values. Now moving on to the applications of this TLC technique. Now thin layer chromatography technique can be used for the separation and identification of analgesics, antibiotics, amines, amino acids, alkaloids, glycosides, sugars, vitamins and pharmaceutical drugs. So it is used for the detection of impurities, and one can also assess the purity of the compound. Most importantly, TLC technique is used to monitor the progress of a reaction. So a chemical reaction can be monitored by employing TLC technique. Both qualitative as well as quantitative analysis can be performed by this technique. And TLC is used to determine the solvent system and to monitor the column fractions. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.